Welcome to my Lab 5 video. I'm Thuvarakaa and I will be presenting the electromagnetism behind speakers. A speaker typically consists of a permanent magnet, coil, cone, suspension, and wiring that all work to produce sound in accordance with the principles of electromagnetism. This schematic shows the breakdown of my design. These structures are homologous to the parts of the speaker shown earlier. Here we have the bottom cup and the permanent magnet system. This is where the bottom plate magnet of the magnet system shown before is taped to the bottom cup to provide stability for the column magnets and the plate magnet above. The copper coil in which the alternating current will go through is taped to the top cup here, where it's coiled up in multiple turns. The coil will act as an electromagnet once current begins to flow through the coil, and this is explained by the Biot-Savart law, where the flow of charges induces a magnetic field for the wire, which can now interact with the permanent magnet to demonstrate vibrations. Faraday's law of induction explains that when a conducting coil is in proximity of a time-changing magnetic field or magnetic flux, a voltage is induced in such a coil. The negative in the Faraday's law can be attributed to Lenz's law. This is the finished product. The flaps taped to the inside of the top cup helps to suspend the cup a bit above the magnetic system, and the top cup helps to showcase a better vibration, thus allowing for a stronger sound wave to be heard by the ear. Now we have the results, where we can see that the AC signal frequency increases, and in response to that, the pitch heard increases as well, and this is in the following video.
I think I'm just not spinning it fast enough.
Yeah, it was spinning really fast.
If we could gear it or something and make it go really fast, I bet we'd generate all kinds.
The electromagnet's polar orientation switches periodically in accordance with the frequency of the AC signal, thus creating a repulsive and attractive force between the coil and permanent magnet, as shown here, thus creating a sound wave shown by vibration, which can be detected by the ears. Reflecting on this lab, the understanding of how a simple speaker works in the lens of electromagnetism demonstrates the connections that tie the various laws of this phenomenon together. Faraday's law and Lenz's law complement each other, where Lenz's contributes to the Faraday's law as described earlier in terms of the negative on the expression. The Biot-Savart law demonstrates the behavior of electromagnets and the importance of using AC current rather than DC current for an application such as a speaker. The property of direct current is inapplicable for speakers, as the electromagnet's poles will not alternate to cause the periodic repulsion and attraction forces that would be between itself and the permanent magnet. The process of building the speaker involved understanding the outlined principles during this video so that it can be ensured that the speaker is adequately built and components are not neglected. Thank you for watching my video.